In this lecture, we will study series solution of differential equations. Okay, means we will solve the differential equation by power series method. So, what is power series? So, an infinite series of the form sigma n is equal to 0 to infinity cn x to the power n. Okay, means this thing equal to c0 plus c1x plus c2x square plus up to so on, where c0, c1, c2 up to so on, these are constants. Okay, so we will solve a differential equation by using this method. So this is called series solution method. Also, this is called integration in series. So a differential equation of second order in the form, this is d2y upon dx2 plus px dy by dx plus qxy equal to 0. So this is a differential equation of second order, where p and q are functions of x alone. Okay, so as we know, linear, what is the meaning of linear? So as we know, in any differential equation, what is degree and order? So order means here y is dependent and x is independent. So first we see how many differentiation of y with respect to x in whole differential equation. So maximum 2 times, because d2y upon dx2. So this is order. And degree of maximum order of differential equation is called degree of differential equation. So degree of this differential equation is 1. So this is linear. This is linear differential equation. So as we know, this type of differential equation can also be solved by general method. Okay, but in this lecture we will explain by series solution method. Okay, so here this is very interesting that here coefficient of d2y upon dx2 is 1, but some questions we will get this is some function of x. So this is the difference of questions. So you see very carefully this type of questions. Okay, so suppose this is an standard form. Here p and q are functions of x. So first we study the nature of this differential equation, means at origin what is the value of p and q. Okay, means at x is equal to 0, what is p and q. So we divide in two category. Okay, so first category is when p and q are not infinite at x is equal to 0, means px not equal to infinity, qx not equal to infinity at origin, then this point x is equal to 0 is called ordinary point. Okay, and similarly, if px and qx are infinite at x is equal to 0, then this point is called singular point. So we shall explain the method of differential equation by these two categories. First we see what is the nature at x is equal to 0 of p and q. So if p and q does not infinite, means they are not singular point, so we will solve by taking a series, simple series y equal to cn x to the power n, means we will take simple y is equal to this thing. Okay, but if our differential equation p and q are infinite, means x is equal to 0 is singular point, then we will take the series of the form y is equal to x to the power k and this cn xn. Okay, so this is the difference between two categories. Okay, so first we will see our differential equation very carefully and we calculate p and q. So if at x is equal to 0, P and Q are not infinite, then x is equal to 0 is called ordinary point. And in this case, we will take the series y equal to Cn xn. And if x is equal to 0 is a singular point, means P and Q are infinite, either both infinite or at least one infinite. Okay, so x is equal to 0 is called singular point. In this case, we will take a series of the form this thing. Okay, so first we take this series and we differentiate with respect to x, means dy by dx, d2y upon dx2, and then we will put the value of dy by dx, y, d2y upon dx2 in given differential equation. Okay, and then we calculate the constants. Okay, then we will get our solution. Also, singular point have two categories. Okay, how many? Two categories. One is regular singular point and other is irregular singular point. So we will explain in further lecture, because I want to explain one equation by this category. Okay, means when a point is ordinary point, so I want to solve an example by taking this series. Okay, so now this is an example of a differential equation, means solve by power series method. So this is a differential equation. This is a differential equation of first order and first degree. Okay, so this can also be solved by general method, means by variable separable method. Okay, but our aim to explain by power series method. Okay, so how we solve? So here first we check at x is equal to 0, at x is equal to 0, this is an ordinary point, means here x is equal to 0 is an ordinary point. As we explained before, how we check? So if we put x is equal to 0 here and here, means coefficient of dy by dx and y. So if we get finite number, then this is an ordinary point. Okay, therefore assume that the series solution be y is equal to c0 plus c1x plus c2x square plus c3x cube plus up to so on. So first we see given differential equation. Okay, and x is equal to 0 is an ordinary point or not, and then we put the solution of the form this. Okay, so suppose this is given equation number 1. So what is our aim? Our aim is that here y is equal to this thing, so we calculate dy by dx. Why? Because only we need first derivative. So now differentiating, this is second. Now differentiating this value of y with respect to x. So dy by dx equal to 0 plus c1 plus 2 c2x plus 3 c3x square plus up to so on. Okay, so now substituting the value of y and dy by dx in given equation. So substituting the values of y and dy by dx in given equation 1. Okay, so we get dy by dx minus y equal to 0 means c1 plus 2c2x plus 3c3x square plus, okay, this is dy by dx, minus y means c0 plus c1x plus c2x square plus up to so on equal to 0. So now our aim is that we collect same power of x, terms of same power of x. So here this is constant c1 minus c0, so c1 minus c0 plus coefficient of x, so 2c2 minus c1 x, coefficient of x square, so plus 3c3 minus c2 into x square plus up to so on, this is equal to 0. Okay, so now right hand side can also be written as 0 plus 0x plus 0x square plus 0x cube up to so on, means equating to 0 coefficients of constant, coefficient of x, coefficient of x square up to so on. Okay, so now equating the coefficients of each power of x to 0, we get c1 minus c0 equal to 0, 2c2 minus c1 equal to 0, 3c3 minus c2 equal to 0. So here we see very carefully that c1 is equal to, from first c1 is equal to 0 means c1 is equal to c0, sorry, c1 is equal to c0. Now here c2, so c2 is equal to c1y2, and already c1 is equal to c0 means c2 is equal to c0y2. Here c3, so 3c3 is equal to c2 means this is equal to c3 is equal to c2y3. Okay, so we see here all the values in terms of c0. Okay, so here c3 is equal to c2y2 and c2 is equal to c0y2. So c3 is equal to c2 is nothing but c0y2, so 1 by 3 c0y2. Okay, and similarly we can calculate all the constants in terms of c0. So here it is very clear that our values are c1 is equal to c0, c2 is equal to c0 upon 2, c3 is equal to c3 is equal to 1 by factorial 3 c0, means this can be written in terms of factorial. So this thing, now substituting the value of c1, c2, c3 in given series. Okay, so what is the solution? Y is equal to c0 plus c1 is c0, c0x plus c2 means c0 upon factorial 2 x square plus c3 means c0 upon factorial 3 x cube plus up to so on. So here c0 is common, so c0 1 plus x square upon factorial 2 plus up to so on. So this is the solution, means this is the answer of given equation. So this is very easy to solve, means if given equation will be solved by power series method. So first we see given differential equation, and first we see what is P and Q. So at x is equal to 0, if P and Q are not infinite, so we say given differential equation, for given differential equation x is equal to 0 is an ordinary point. So we take the series of this form, okay, and then second step is that we calculate dy by dx, then putting y at dy by dx in the given equation 1, and then we equate the coefficients of x square, x cube with constant is equal to 0, and then we calculate the values of constant, means c1, c2, c3 in terms of one constant, and then putting all the values in given series. So this will be answer, okay. So this is next example, means find the series solution in powers of x of the differential equation, okay, means we will solve by series solution method. So given d2y by dx2 plus xy equal to 0, okay. So first we see very carefully our given differential equation, okay. So here coefficient of d2y upon dx2 is constant, means 1, y is x, it means capital P, capital Q are not equal to infinite at x equal to 0, okay. So first we check what is the nature of P and Q at x is equal to 0, okay, means P and Q are finite value, therefore first we see here x is equal to 0 is an ordinary point, okay, is an ordinary point. So we take the solution of this equation is, so we take the solution of given equation 1 is y is equal to c0 plus c1x plus c2x square plus c3x cube plus cn xn plus so on, means this is a series of the type cn xn, n is equal to 0 to infinity. So first thing you see very carefully, okay. Now since given differential equation of order 2, it means our solution contains only two constants, okay. So what is the next thing which is important? Order of this differential equation is 2, it means our solution will be contain only two constants, okay. So now this is the solution. So first we differentiate equation 2, so dy by dx equal to dy by dx is equal to c1 plus 2 c2x plus 3 c3x square plus n cn xn minus 1, okay. So nth term is very important because we will calculate all the values by using this. So d2y by dx2 is equal to here 0 plus 2c2 into 1 plus 3 into 2 c3x plus n minus 1 cn xn minus 2 plus to so on, okay. So this is very easy to calculate dy by dx and d2y upon dx2. Now, substituting the values of y and d2y upon dx2 in given differential equation 1. Okay, so we get d2y upon dx2 plus xy equal to 0, means first we put this value and then y. Okay, so we get here 2c2 plus 3 into 2 into 1 c3x plus n minus 1 cn x n minus 2 plus, means this is y2. y2 is nothing but d2y upon dx2 plus x into y. y means c0 plus c1x plus c2x square plus cn xn plus equal to 0. Okay, so now we collect the terms which contains same power of x, means first we collect constant and then coefficient of x square up to show on coefficient of x to the power n. Okay, so now constant term. So what is constant term? Constant term is 2c2. So 2c2 plus coefficient of x. So here 2 into c3 plus c0. Okay, now coefficient of x square. So next term plus 4 3 c4 and then c1x square, means plus c1 x square plus. Now this is important, coefficient of x to the power n. Okay, so here x to the power n minus 2, means this is coefficient of x power n minus 2. So we need coefficient of x power n. So how we put? So n is equal to n plus 2. Okay, so plus n plus 2 n plus 1 c n plus 2. When we put n equal to n plus 2, so then we get coefficient of x to the power n. So this thing, and here this is x to the power n, but if we multiply here x, so we get x to the power n plus 1. So here we put n is equal to n minus 1, because here multiplied by x, so this is x to the power n plus 1, cn x to the power n plus 1, so plus cn minus 1, and this is the coefficient of x to the power n plus so on equal to 0. So this is very important, means coefficient of x to the power n you calculate very carefully. Now equating the constant terms, coefficient of x square, etc. equal to 0. Okay, means equating the first constant term, coefficient of x, coefficient of x square up to coefficient of x to the power n of our equation equal to 0, means separately we will put 0. So we get first 2c2 is equal to 0, 2c2 is equal to 0, next 3 into 2 c3 plus c0 is equal to 0, next 4 into 3 c4 plus c1 is equal to 0, and nth is n plus 2, n plus 1, c n plus 2 plus c n minus 1 is equal to 0. Okay, so this is important, that this term is very important because this is general term. Okay, so first from here we put 2, 3, 4 and 5. Our aim is to calculate the values of constants, means C0, C1, C2, C3 up to so on. So first we see here, so C2 is equal to 0. Okay, and then next here C3, so C3 is equal to minus C0 upon 3 into 2. Here C4 is equal to minus C1 upon 4 into 3. Okay, C4 is equal to, and from here Cn plus 2 is equal to minus Cn minus 1 upon n plus 2 n plus 1. Okay, so this is very important because now our aim is to calculate all the constants, and also we know our solution will contain only two constants. Okay, because given differential equation of order 2. So now C2 is equal to 0, so here C3 is equal to C0, C4 is equal to in terms of C1, so C0 as it is C0 and C1 C1. Since C2 is equal to 0, the all term which contains C2 vanish. Okay, so now from here if we put n is equal to 1, so C3, so C3 is equal to minus C0 upon n is equal to 1, so 1 plus 1 2, 2 plus 1 3. Okay, so 3 into 2 already we have calculated from here. Okay, so C n is equal to 2, so C4, here C4 is equal to minus C2 minus 1 1 upon 2 plus 2 4 into 3. Okay, so this can be calculated from general term. Okay, now C5, what is C5? If we put n is equal to 3, to minus 3 minus 1 2 upon 3 plus 2 5 into 4. Okay, C6, so C6 4, n is equal to 4, so minus C3 upon 6 into 5. So this is very easy to calculate. It means we can calculate all the constants by general condition, means coefficient of x to the power n. Okay, substituting the value of C0, C1, C2 up to so on in given series, means y is equal to C0 plus C1ax plus C2x square plus up to so on. Okay, so here y is equal to C0 as it is plus C1. What is C1? So C1 is as it is. Now C2 is 0, so plus 0 x square. What is C3? So minus C0 upon 3 into 2 x cube. C4, so minus C1 upon 4 into 3 x4. And then C5 again contains C2, so 0 x5. C6, so minus C3 upon 6 into 5 x6 plus up to so on. Okay, so here since C3 in terms of C0, so here we will write in terms of C0, so this is equal to C0 plus C1x minus C0 upon 3 into 2x cube minus C1 upon 4 3x4. This is 0 minus what is C3? C3 is C0 upon 3 2. So plus C0 upon 3 into 2 and 6 into 5 x6 plus up to so on. Okay, so now there are two constants means C0 and C1. So C0 here, C0 1 here plus minus 1 upon 3 into 2 x cube plus 1 upon 3 2 6 5 x 6 minus up to so on plus C1 coefficient of C1. So x here minus 1 upon 4 into 3 x 4, okay, plus so on. Means this is a solution. Okay, y is equal to C0 function of x plus C1 function of x. So because our given differential equation is of order 2, therefore solution contains two constants. So this is answer. This is very easy. Okay. Now second case means when x is equal to 0 is a singular point. It means when x is equal to 0, capital P and capital Q are infinite. At least one infinite or both infinite. So in this case, this is called singular point. Okay. So singular point divided in two parts. Okay. Singular point divided in two parts. One is called regular singular point. One is called regular singular point. Okay. And second is called irregular singular point. Irregular singular point. Okay. So what is the definition of regular singular point? So if x px and x square qx can be expanded as power series in x at x0, then x is equal to 0 is regular singular point. Okay. And what is irregular singular point? If which is not regular singular means a singularity which is not regular. Okay. So this is not important, only we will discuss about regular singular point. So you remember in the case of singular point we will take the series y is equal to xk and then c0 plus c1x plus c2x square plus up to so on. Means what is the difference of two series? We have when x is equal to 0 is ordinary point, then we will take only series y is equal to this will not take. Okay. So in the case of singular point, what is the difference? We multiply by this thing x to the power k and then old series. So this is the difference. So first we check our given differential equation. At x is equal to 0, p and q are infinite. Then we say x is equal to 0 is a singular point. And in this case, we will take the series of the form y is equal to x to the power k sigma cn xn. Okay. So this is the difference. Now, this divided two parts. One is regular singular point and second is irregular singular point. So what is regular singular point? So if x px and x square qx can be expanded as power series of x, okay, then x is equal to 0 is called regular singular point. And if it not possess a singularity this type, so this is called irregular singular point. So you remember, we will discuss only means importance of only regular singular point of our syllabus, okay.